so this section is 9.4, absolute value inequalities. If we start with something pretty easy, if I said the absolute value of x equals 2, what are the two answers to this one? We don't have to set up case 1 and case 2 for this one. You should know the two numbers. This is not an inequality either. This is an equation. So quick review. What are the two numbers whose absolute value is equal to 2? Thank you. 2 and negative 2. So here's 0, here's negative 2, and here's positive 2. And it would just be a closed dot on 2 and negative 2. Does everybody agree with that? Those are the only two numbers that work. Okay, if I said the absolute value of x is less than 2, okay, sometimes setting up the case is really helpful. What numbers have absolute values that are less than 2? One, I heard 1. Absolute value of 1 is what? What's the absolute value of 1? 1. Okay. What about 3? What's the absolute value of 3? Is that less than 2? No. Okay. So what about negative 1? What's the absolute value of negative 1? 1. Is 1 less than 2? Yes. So if you are looking for an absolute value of something to be less than 2, then it would be all the numbers that would be between negative 2 and positive 2. Does everybody agree with that? Even the little decimals. 1.3. The absolute value of 1.3 is less than 2, correct? Okay. Let's go to the next one. Absolute value of x is greater than 2. Where would that one be? That's right. Because, give me some examples of numbers less than negative 2. Okay, so negative 5. Absolute value of negative 5 is what? 5. Is 5 greater than 2? Yes. Okay, what about positive 10? That would be over here to the right, wouldn't it? The absolute value of positive 10 is 10. Is 10 greater than 2? Yes. Okay, so it would look like this. Now, what this leads me to is that, and it's in your workbook on page 357, where it says review and complete. If A is a positive real number, then the inequality absolute value of x is less than A is equivalent to negative A is less than x is less than positive A. This one corresponds to that concrete example that I gave you over there. I ended up shading from negative 2 to positive 2, didn't I? So we could have written this answer, let me use a different color, as negative 2 is less than x is less than 2. That's how that inequality could be written. Okay, this one could be written x is less than negative 2 or x is greater than positive 2. And this one is just equal because it was an equation. So number 3 on that review and complete says if absolute value of x is greater than A, now A has to be positive, okay, for this to be true, positive real number, then that means that x is less than negative A or x is greater than positive A. So what I'm trying to tell you is this. If you have if you are given a problem that says the absolute value of some stuff, I do not care what the stuff looks like inside there, is less than a number, you are going to assume it is an intersection problem. Because isn't this an intersection inequality that we just talked about a little bit ago? If you have the absolute value of some stuff is greater than a number, and the equal to bars can be under there. Those are flexible. If they're under there, that's fine. It's a union problem. So let's look at an example. Absolute value of t minus 4 plus 1 is less than 6. So the very first thing you have to do is you have to isolate the absolute value. So I'm going to subtract the 1 from both sides. Now, absolute value less than a positive real number, according to this right here, it means that I can set it up as, so this means, here's your rules up here. It's this one, isn't it? Negative a, well a is 5 here, so negative 5 is less than whatever's inside the absolute value is less than positive 5. And then you can solve it. That's what that rule means. So I'm going to add 4 to both sides, to all three sides. And I get negative 1 is less than t is less than 9. Now, if they don't ask you to graph it, they're probably just going to ask you to write the solution set, which would be, I think they're going to ask you to do it in interval notation. So it would be from negative 1 to 9. It would be all the numbers between negative 1 and 9. You could even check some of them, like randomly pick a number between negative 1 and 9, 1, and put it in there and see if you get a true statement. So 1 minus 4 is negative 3. The absolute value of negative 3 is 3. 3 plus 1 is 4, and 4 is less than 6. Okay? You always, always, always make a note of this. Keep the absolute value expression on the left side. Very important. That's actually on page 358 where it says it says review and complete. It is generally easier to solve an absolute value inequality if the absolute value appears on the left side of the inequality. So you always just want to keep it over there because it'll make way more sense to follow your rules. Okay? All right, let's do another one. Okay? So the first thing we have to do is isolate it. So I'm going to add 2 to both sides. it's greater than, which means you're going to follow the rule up here. Absolute value of x is greater than a means x is less than negative a, or x is greater than positive a. So x is this stuff inside here. So it's c plus 3 over 2 is less than negative 6, or c plus 3 over 2 is greater than positive 6. These are your two cases that you're setting up. Okay, you're just using the little summary rule that we came up with at the beginning to do so. I'm going to multiply both sides by 2 to get c plus 3 is less than negative 12. Subtract 3. C is less than negative 15. Or multiply by 2 again. C plus 3 is greater than 12. Subtract 3 from both sides. So C is greater than 9. If we were to graph that on a number line, it would be an open circle on 15 shaded to the left and an open circle on 9 shaded to the right. You can test points in each one of those and see if it works. Interval notation would be from negative infinity to 15, union with 9 to infinity. I'm not going to show you concept 2, which is solving by the test point method. I don't really see the need in that when you can simply use, the beginning and the notes and the rules that we got up there. Just always keep your absolute value on which side? The left. So if it's not on the left, you need to put it on the left. So I've got absolute value, let me change colors. Absolute value of 4x plus 7 plus 10 is greater than 9. Okay, subtract 10 from both sides. Is this true? Is the absolute value of something greater than negative 1? Yes. Just can't equal it. And it can't be less than it, can it? But it is greater than it all the time. What do you think? I think this is true for all real numbers. They don't give me a lot to work with in my book to know where they're wanting me to lead you here. But this is true for all real numbers, isn't it? Any number that I put in here and take the absolute value of it will always be greater than negative 1 because the absolute value is positive at all times. And a number that's greater than negative 1 is positive at all times. So this is all reals. X can be any number in there by sheer common sense. What if I had given you this? Absolute value of x plus 3 is less than negative 7. Absolute value can't be negative, and the only numbers that are less than negative 7 are negative numbers. So can the absolute value of something be less than a negative? No. No solution. I think they are doing this with the empty set. So again, we get into that robot mode and we want to just keep on solving and doing what we're doing, but you got to think when you're doing absolute values. Okay? You have to think, can this even be true to begin with? Or is it always true to begin with? This one was always true. And this one is never true. Any questions? We're finished.